guys, Rex here. Quiz time. We're going to use the flag method to indicate wind speed and direction. Typically, what people will do and the way they say it works is if you have a wind flag or a wind sock, you take the angle the flag is blowing and divide that angle, the degrees, by 4, and that'll give you your approximate wind speed in miles per hour. Now, it's kind of an old method. It's in the old FM 23-10 manual. Now, here we have two flags that you can see, one in the foreground on the left part right there, and we have the one out here, okay, which is a little bit farther down. So what direction is the wind blowing? Well, you see the one on the right, a little bit farther away, is blowing pretty hard from north to south. This is south going in that direction there, okay? And so it's blowing pretty hard right there. You almost got 80 degrees straight across, would be 90 degrees of an angle. And so you can take that number divided by 4 and you'll get your wind speed, okay? Now this other one, right up here on the left, the closer one, that one is kind of changing directions and it's not near as much wind speed there. And when it does pick up, a minute ago it was blowing very strong towards us. Now it's kind of blowing a little bit weak away from us. And so one thing you have to take note of here is, and this works if you're running an anemometer or a flag or any wind reading equipment at all, okay, is you have to realize that there might be objects on the topography, like a giant building like that right there, which would totally change the direction of the wind exactly from where you're measuring it from, okay? So like basically what we have is the wind coming from the north on the other side of the building, trying to get around this giant building, and now the wind is sucking in from both the west and the east side of this building, you know, trying to get from the north to the south side. And so here on this flag, you can see it's kind of blowing away from us. The wind's coming around from the north, coming in this direction, and then pinching back in to fill in that negative pressure zone, kind of like it's tailing back in there. And so that might change as the direction slightly changes. Now the flag over there, you can see is definitely blowing in a pretty consistent fashion due to the position of the flag, not immediately next to as large of a building. That's actually a little bit on this side of the building that is sitting next to the other hotel there. And so it would be more of an indicator. Now, if either of these flags, even though they're both blowing in opposite directions and they're within 100 yards of each other, you know, it can be deceiving if you're not very, very cognizant of the local topography immediately where you're at in your firing position. Potentially, let's pretend we had a firing line somewhere in the shelter of the wind next to this building, kind of underneath that pavilion or something. Okay, let's say that that's what was going on, and we had to get a wind reading. And what a lot of guys will do is get out their anemometer, they'll put it on their little tripod with the little wind vane on there, and they'll get their direction and their wind speed based on that. Well, that's the one spot where the bullet is actually not flying through the air. They should be more worried about like what's going on way over there, right? Okay, it's very common for guys to forget that the wind at your position is often not the wind downrange, especially if you're shooting pretty far, because once you get away from cover where you're laying, most shooters like to lay in a covered position by some bushes, the benches with the covered roof, all the cars parked behind you. That will change dramatically depending on the scale and how close you are to these objects. Just like a compass will be thrown off if you're standing too close to metal, it'll throw off your measurement, okay? And so now we have the two flags kind of agreeing, sort of, but it is changing back and forth. Like when I first rolled up here, that closer flag was blowing very strong in my direction. And that's subtle, angular differences to where which side of the building is the wind going to rush around the most. Now it's kind of sort of pointed at us. And so you can see if I was going to take an anemometer reading there versus on the other side of the building, on the far side by the other flag that's blowing strong, I'd have two totally different stories. And so I hope that helps you guys. You need to look around you when you start taking wind readings. You need to observe the overall direction of the mass of air blowing in the sky. You need to look at what direction the clouds are going. You need to think about what is the wind having to navigate around what objects are going to change it, how is it going to change it. It's a fluid, and it hits objects, and it has to move in different ways. So where are you positioned in that local topography to get that reading? Whether it be a flag, a piece of yarn, an anemometer, which are very accurate if run properly, but that still it's all up to the operator to understand that your position is the one spot where the bullet is not flying. That bullet is flying down range. That's where the wind is going to have its effect, is, in between you and the target, and not necessarily immediately at your firing position, okay? And so don't forget about that when you're doing your wind readings.